Structured query language is a domain-specific language used for managing and manipulating relational databases. It serves as the standard language for interacting with databases and is used for tasks such as creating, querying, updating, and deleting data within a database. In order to learn SQL theory and practice, let's first understand the basics of databases. If you're not already familiar with them, you will learn now. If you already know, this will be a quick recap for you. Databases are organized collections of data that are designed to store, manage, and retrieve information efficiently. They are crucial components of modern software systems used for various purposes ranging from simple data storage to complex data analysis. Here are some basics about databases and data attributes that you should know. Number 1. Databases. A database is a structured collection of data that is organized, stored, and managed in a way that allows for efficient retrieval and manipulation of information. Databases are used to store various types of data, including text, numbers, images, videos, and many more. Number 2. Data attributes. Data attributes, also known as fields or columns, are the individual pieces of information that are stored within a database. Each attribute represents a specific characteristic or property of the data being stored. For instance, in a database containing information about customers, attributes could include name, age, address, and much more. Number 3. Types of data attributes. There are different types of data attributes, each suited for storing different kinds of information. Text string, used for storing alphanumeric characters such as names, addresses, and descriptions. Numeric, used for storing numbers which can be further characterized into integers, decimals, and much more. Date and time, used for storing date, time, or timestamp information. Boolean, used for storing true, false, or binary values. Binary, used for storing binary data like images, videos, or documents. Enumerated, used for storing a predefined list of values like male or female. Number 4. Primary key. A primary key is a unique identifier for each record row in a database table. It ensures that each record can be uniquely identified. It helps in maintaining the integrity and consistency of the data. Commonly used examples of primary keys are customer IDs, product IDs, or social security numbers. Number 5. Data types. Each data attribute has a specific data type associated with it. Data types define the kind of values that an attribute can hold and determines how the data is stored in the database. Examples of data types include integers, strings, dates, and more. Number 6. Data integrity. Data integrity refers to the accuracy, consistency, and reliability of data stored in the database. Databases are designed with constraints, rules to enforce data integrity, such as ensuring that primary keys are unique and the data values conform to specific formats. Number 7. Relationships. In relational databases, data attributes from different tables can be related to each other through keys. Common types of relationships include one-to-one, one-to-many, and many-to-many relationships. These relationships help in organizing and retrieving related data efficiently. Number 8. Databases management systems. A database management system is a software that provides an interface for users and applications to interact with databases. It handles tasks like data storage, retrieval, manipulation, and security. Popular DMS include MySQL, PostgreSQL, Microsoft SQL Server, and Oracle. Anyone involved in data storage and management must have a solid understanding of databases and data attributes. Applications ranging from simple data storage systems to complex enterprise-level software solutions rely on them. Now here's a comprehensive overview of SQL. Number 1. Relational databases. SQL is primarily designed for relational databases which organize data into tables with rows and columns. A relational database consists of multiple tables, each with a unique name and predefined structure. Within the tables are columns, which is for use for the data attributes to store the data. Number 2. Basic SQL commands. Select. Select retrieves data from one or more tables based on the specific criteria. Insert. Insert adds new rows, records into a table. Update. Update modifies existing data within the table based on specific conditions. Delete. Delete removes rows from a table based on specific conditions. Number 3. SQL data types. Data types define the kind of data that can be stored in a column, such as integers, strings, dates, and more. Common data types include integer, varchar, date, float, boolean, etc. Number 4. Querying data. The select statement is used to query data from tables. You can use conditions where clause to filter results, and you can order results using the order by clause. Number 5. Filtering data. Where clause is used to filter rows based on specific conditions, logical operators and or not and comparison operators equal, greater than, less than are used in conditions. Number 6. Sorting data. The order by clause sorts query results based on specific columns in ascending or descending order. Number 7. Joins. Joins combine data from multiple tables based on related columns. Common types of joins include inner join, depth join, right join, and full join. Number 8. Aggregation. SQL supports aggregation functions like count, sum, av, min, and max to perform calculations of group data. Number 9. Grouping data. The group by clause is used to group rows by one or more columns, is often used in combination with aggregation functions to summarize data. Number 10. Subqueries. Subqueries are queries nested within another query. They can be used to retrieve data for conditions, calculations, or comparisons. Number 11. Updating data. The update statement modifies existing data in the table based on specific conditions. Number 12. Deleting data. The delete statement removes rows from a table based on specific conditions. Number 13. Creating tables. The create table statement is used to define the structure of a new table, specifying column names, data types, and constraints. Number 14. Constraints. Constraints ensure the data integrity by imposing rules on the data stored in tables. Check constraints include primary key, foreign key, unique, not null, and check. Number 15. Indexes. Indexes improve query performance by providing a fast way to look up rows based on indexed columns. Number 16. Views. Views have virtual tables created by querying one or more existing tables. They can simplify complex queries and provide a controlled access mechanism to the underlying data. Number 17. Transactions. Transactions ensure data consistency and integrity by grouping SQL operations together. There's something called ACID. ACID stands for atomicity, consistency, isolation, durability. These properties define the behavior of transactions. Number 18. Database management. SQL is not only about querying data but also about managing databases, including creating, altering, and dropping databases and tables. Number 19. Database administration. Database administrators (DBAs) are responsible for managing and maintaining databases, including performance tuning, backup, and security. Number 20. SQL variants. Various data systems implement SQL with slight differences. The most widely used variants are MS SQL, PostgreSQL, SQL Server, Oracle, and SQLite. Number 21. SQL limitations. SQL is designed for structured data and relational database. It might not be suitable for unstructured or complex data types. To summarize, SQL is a powerful tool for working with relational databases and understanding the fundamental concepts and commands. It's essential for anyone involved in data management, analysis, or software development. To install dbeaver. dbeaver is a free and open source universal database tool for developers and database admins. So the reason we're going to install this is to run our SQL commands and learn more about it. So let's get started. Just a quick overview. So dbeaver is good because of its usability. The main goal of the project is to give you a program UI which is carefully designed and implemented. It is free, it is open source. It allows for various plugins. It may handle any external data source which may or may not have a JDBC driver. And it also offers multiple features. So what we're going to do now is we're going to go to download. And then we're going to install it for the system you're on. So it could be one day Windows, Mac, or Linux. For me, I'm going to do this Mac. So as you can see, it is downloading now. Just give it a moment for it to download. And once it's done, you're going to open the file. You're going to move it into your applications. Yes, you can just keep both. And now what you're going to do is you're going to go here. We're going to put dbeaver. This is the application you're going to open in. As you can see, it is getting started, and the best part is, if you're learning SQL, you don't have to paper it anything in Pocket. Now, do you want to create a sample database here? Please press yes, because that's what we're going to use to learn. Do not send. So as you can see now, you have this, and then what you're going to do is you're going to click here. Okay, saying you got to download the driver files, which is good, so you can click on download. And then you can see you have bunch of tables, which is album, artist, views, indexes. So what we're going to do now, and you can look into the project as well, we're going to open our SQL, and we're going to go back to our database, and we're going to write a simple command. Select, okay, we're going to say, let's say, album, look into your columns, album ID, from album. Okay, and then you're gonna click here. Now this is the SQL terminal, and then you can see what the data are in. So this shows you how you have successfully download and are using dbeaver. So now let us get started to learn SQL from the sample database. What we are going to be doing is we're going to be using different SQL statements to learn about SQL. So let's get started with the first most common statement, which is a select statement. So the select statement just tells you, or more of to the system, okay, this is what you need to return back to me. So what we're going to do is we're going to do this wildcard star. So this star would give you everything from the table that you're looking for, but you have to tell it what exactly are you looking for by looking at from. So give me everything from the album, let's say, that table. So now what we're going to do is we're going to run it. And as you can see on the bottom, the album ID has come up, the title, the artist ID, and everything else. Now what we're going to do is we're going to remove this, and we're going to tell it to give us only distinct values. What distinct value means is what the word says, only the unique values. Okay, so you see these things also come up. So give me the distinct values of, let's say, of artist ID, because as I can see here, there are some repetitions. So you have to correctly list out the query. And again, where are we getting this from? We're getting this from the the album table. Okay, so before we move on, you see how we got 200. Now with this, we are going to get less than 200. Because it's going to give us only the IDs, but as we can see, the IDs are unique, which means that each ID, there was no distinct ID out there. Okay, so now we're going to move on to the next statement, where. So the where clause is just a way for you to tell, okay, get me this from here, where there is XYZ. So let's use something else. Maybe let's use artist this time. So let us look at the columns. So we have artist, we have name. What about customer? With customer, do we have, okay, so customer, we have more variety. We have the address as well. Just looking at the address type, okay, the data type is varchar, number is 5. I'm thinking, okay, how about we do this? Select customer ID. From customer. Let's see what kind of data do we have before we actually get started. So before we move on, quick thing, the reason why I didn't use artist was because artist had only 2 columns, only 2 data attributes, but I wanted more data to play around with. So let's click on run. Let's see what comes up. Okay, and customer ID came up. What happens when we do this? Let's see what kind of data is there. First name, company, address, city. How about Oslo? How about we do Sai? So what I'm gonna do here, I'm gonna say where, condition, and then I'm gonna say city. Okay, you see city is equal to, I'm gonna copy paste in. Okay, and then semicolon. Let's run it. Okay, so we only found 2 records, so from the big data set, only a subset came. So this was for the where one. Now let's learn more about and, or, and, not. Okay, so these are the conditions that you can use within your where. This is more like the logical statements. Give me city where it is this, or give me a city where there's stat. What I'm gonna do now is I'm gonna go back. I'm gonna play around the data a little bit more to see what other filter I can introduce. Country, Brazil, phone number. So customer is good too. Let me try to look in my employee data. What kind of, oh, okay, so this is also good. We have employee ID, first name, last name, title, hire date, address, city, state. Let me look at employee data. Okay, so we have only 8 records showing up in the employee data. Let's see if all of them are in Canada. Is there any repetition that we can use? Not really. What about the city? Okay, so how about we do this? You use 2 cities from Canada using and or. So let's do where city is equal to, let's say, city A. Or we could have also used, and, but we're just playing around. Let's use Lethbridge. Now, if a spelling is one way and you put it another way, it's not going to run, so you have to be careful with it. Alright, let's see what comes up. Oh, I have an error. Let's see what I did wrong here. Oh, yep, this thing. Yeah, instead of equal, I put this random thing. Let me just space it out. Okay, perfect. So you see how there were like more records, but now it's all giving us either or. And now if we replace this with and, nothing is gonna show up. And just let me do this. And the reason why nothing's showing up is because as employee can't live in one city and the other one as well. Okay, so this one was for city. Now let us do order by. Order by is another good one. So let us use this data and see order by, let's say, what attribute? Yes, one to city, let's just city. And then order by city in ascending order. Now let's use ascending order A, S, C. And now let's run it. So you see how when you look at the city, everything is in ABC order. So that's what order by means. Now let us do one min and max value, syntax. Using that, let us look at maybe employee database. Let me see what we can play around. How about we try to do employee ID where, let's do min, and then let's put the column name of employee ID. So this will tell us when we run it, which one is the minimum employee ID, which we can see is 1. How about if we wanted to see the maximum, not the minimum? So when we do that, we will get 8. So 8 is the maximum value. Okay. So this is how you find min and max, by putting it into the condition. Now what we're gonna do is, let's do count. If I wanted to count how many employee ID I have, count, you put it here. It shows you 8, okay? And if you wanted average, you would use, I don't know if you would want to do average for employee ID, but just for the sake of it, what I'm going to put here is average. Oh, the reason why you are getting this error is because you did not put the within the parenthesis the column name, which is really critical. Okay, so I think we covered most of the critical syntax. I'm just going over my notes to see which one we didn't cover, but it's good to do. Let's do a group by, but this time let us use a different data set. So we have invoice. Let's see what kind of attributes we have in invoice ID, customer ID. Okay, so what I'm going to do now is I'm going to go to customer. And I am going to select everything so we can see what kind of data exists here. Customer ID, first name, last name, company, okay. How about we group by everything by the city? And we put city. Let's see how our data looks now. Okay, so our data is organized by the city now. And order by we already did. Okay, so these are the main commands that you really need to know when you're using SQL for basic syntax.